If you can't deliver millions of tons to Earth orbit, you can't get the millions of tons that you need to the Moon and Mars to make us a sustainably multi-planet species.
SpaceX has already laid out a mission that requires 2 Starships to meet in orbit and move liquid methane and oxygen between them. Now, if Flight 14 reaches orbit and returns to the tower, Flight 15 could launch the first ship in that refueling test and leave it circling the Earth. A second Starship would follow later, close the gap, dock, and transfer propellant between 2 9-meter wide vehicles. Now, could Flight 15 become the moment the Starship stops flying alone? The first vehicle may spend far longer in orbit than any Starship before it, and keeping its propellant usable could be harder than reaching orbit. Now, we're going to look at cryogenic boiloff, fuel gauges and microgravity, DragonEye rendezvous sensors, docking hardware, the tanker flight, repeat catches, and the chance that SpaceX eventually reflies a recovered ship. SpaceX has not assigned these goals to Flight 15, so I'll separate the published plan from the most reasonable forecast. Now, Flight 15 has not been officially announced, and SpaceX has not confirmed its hardware or mission plan. What we do have is SpaceX's published sequence for a 2-ship propellant transfer test target for 2026. Put that beside the planned Flight 14 objectives, and a very interesting next step begins to take shape. Flight 14 first has to prove that the new Starship can complete the full trip. That means reaching the intended orbit, deploying useful payloads, restarting its engines for the deorbit burn, surviving entry, steering through the atmosphere, and arriving at the tower in condition for a catch. A clean mission would give SpaceX confidence in the basic vehicle while also producing a mountain of data on the heat shield, flaps, engines, tanks, and guidance systems. Now, once those jobs are working, staying in space becomes the next serious test. SpaceX says the first Starship in its refueling demonstration will launch from Starbase and spend an extended period in orbit. It'll collect data on propulsion, thermal behavior, long-duration propellant storage, and boil-off while it waits for the second ship. Flight 15 is the earliest logical candidate for that role if Flight 14 comes home and if the refueling hardware is ready. That would make Flight 15 very different from the short Starship missions so far. Instead of making roughly 1 lap and heading for re-entry, the ship could remain in orbit for hours or possibly days. It would become a temporary propellant receiver that stays healthy until another launch reaches it. Everything that happens while the ship waits would now count. The biggest problem is temperature. Starship uses liquid oxygen and liquid methane, which must be kept at roughly minus 183 and minus 162 degrees Celsius at normal atmospheric pressure. Heat leaking through the stainless steel walls turns some of those liquids into gas, raising pressure inside the tanks. And the ship can vent that gas, but every kilogram vented is a kilogram that cannot be burned by an engine or transferred to another vehicle. Now, orbit adds another layer of trouble because the thermal environment keeps changing. The ship moves through direct sunlight and then into Earth's shadow, heating and cooling its skin over and over. Valves, pipes, seals, insulation, vents, and electronics all have to work through those cycles without letting tank pressure run away. Flight 15 could give SpaceX its first long look at how the full-size vehicle handles that repeated stress with mission propellant aboard. Now then, there is the strange behavior of liquid in microgravity. On the ground, propellant settles at the bottom of a tank, so measuring it and feeding it into plumbing is fairly straightforward. In orbit, it can spread along the walls, break into floating masses, trap pockets of gas, and slosh when the ship turns or fires a thruster. SpaceX has tested experimental radio frequency gauges that read propellant without depending on a normal flat liquid surface, and a longer Flight 15 mission would be a serious workout for that system. Knowing the propellant level is only part of the job. Before an engine start or transfer, small settling maneuvers may push the liquid toward one end of the tank. They must control slosh while giving the plumbing liquid instead of gas. Now, engineers will watch whether the gauges track every vent, maneuver, and engine firing. The waiting ship could carry hardware that no Starship has used in a complete orbital docking. SpaceX says version 3 ships include docking ports, while the tanker adds docking probes. Starship's ground propellant connection has also been updated for transfer in orbit. Flight 15 may check its valves, seals, heaters, sensors, and flight computer links before another vehicle comes close. For the final approach, SpaceX plans to use DragonEye navigation sensors with experience from Dragon missions. A ship trying to dock cannot depend on ordinary GPS alone once the vehicles are close together. It needs precise, relative range, closing speed, orientation, and position while both spacecraft travel around Earth at about 28,000 kilometers per hour. The dramatic part may look slow on camera, but the computers will be correcting tiny, tiny errors that could otherwise bring two enormous stainless steel vehicles together in the wrong way. Now, Flight 15 could rehearse that work by tracking targets, checking its sensors, and flying controlled attitude changes. It may also perform small engine burns after a long coast to prove that propulsion remains dependable. Power, communications, navigation, and thermal control must keep working beyond the familiar one-orbit timeline. One failure could end the demonstration before the tanker actually leaves Starbase. Starship has moved propellant in space before, though, but not between two ships. During Flight 3, SpaceX transferred roughly 5 metric tons of liquid oxygen between tanks inside the same vehicle. That test helped show how cryogenic liquid can be controlled in microgravity, but it did not require two spacecraft to rendezvous, dock, seal a connection, chill transfer lines, or separate safely. The two-ship demonstration combines all of those problems into one mission. If Flight 15 becomes the waiting receiver, the next launch could send up the tanker. Second ship would need to enter an orbit close enough to the first one, adjust its timing around Earth, and gradually remove the distance between them. Launching into the correct orbital plane is only the beginning because the vehicles could still be separated by thousands of kilometers on the same path. Careful phasing burns would let the tanker gain or lose ground without wasting the propellant intended for the test. The tanker would then approach slowly, use DragonEye for relative navigation, line up with the port, and dock. After the connection is secure, the system may need to cool its lines before full flow begins because warm plumbing can flash cryogenic liquid into gas. SpaceX would have to control pressure in both vehicles, track how much oxygen and methane moved, manage the shifting mass, and keep the stack stable. Now, the ships would finally close the valves, disconnect without a leak, hopefully, back away, and prove that both vehicles remain controllable. NASA's Inspector General calls vehicle-to-vehicle cryogenic transfer one of the largest technical challenges in the lunar landing program. No one has moved these propellants between vehicles at anything close to Starship's planned scale. A lunar mission may require many tanker launches, so one docking is only the start. NASA says the campaign needs launch pad turnaround of roughly 12 to 24 days, making the gap between missions a key part to the test. Now, Flight 15 may still carry a payload even if it begins the refueling sequence. SpaceX has used recent flights to test Starlink deployment, and the larger version 3 ship is built to carry far more useful mass. A batch of Starlink V3 satellites could give the mission an operational purpose, while the ship also tests long-duration systems. The trade-off is that a receiver configuration, docking equipment, extra propellant, and longer orbital operations may take priority over filling the payload bay. Recovery will be another major decision. Flight 14 is expected to attempt the first Starship catch, so a successful grab would immediately raise the possibility of repeating it on Flight 15. The booster version 3 also needs a clean return after its first flight ended, with only 8 of 13 landing burn engines lighting and a hard impact in the Gulf. SpaceX could use Flight 15 to attempt the first version 3 booster catch, while a returning ship might give the tower another chance to prove that recovery can become routine. Catching both stages would be spectacular, but it depends on tower assignments, timing, vehicle condition, and also risk. SpaceX could use separate towers or recover one stage while the other follows a safer profile. A receiver mission creates another option. Leave the ship in orbit for the tanker demonstration and just recover it afterward. And until SpaceX publishes an actual plan, dual recovery remains possible but unconfirmed. The first reflight of a caught Starship is getting closer, but Flight 15 may be too soon for Flight 14 vehicle. SpaceX lists catching and reflying the ship as a remaining reuse milestone. Engineers will probably inspect the first recovered ship, study heat shield damage, and examine its flaps and tanks. And a new ship on Flight 15 is the safer forecast, with a recovered vehicle returning sometime later. Success for Flight 15 may look less dramatic than a tower catch, but the technical scorecard would be absolutely huge. The ship would need to reach a precise orbit, remain powered and stable, control tank pressure, limit propellant losses, measure its liquid accurately, restart propulsion after a long coast, and prepare its rendezvous and docking systems for another Starship. If it also deploys payloads or returns for recovery, those would add even more value without replacing the main long-duration work. This entire plan depends on Flight 14 doing its job, on the transfer hardware being ready. Trouble during operational orbital insertion, deorbit, entry, recovery, or the version 3 booster's landing burn could push SpaceX towards another repeat mission before it attempts the 2-ship test. SpaceX could also choose a more operational Starship flight while it finishes the docking system. Flight numbers move, hardware changes, and the first part of the refueling demonstration could slide beyond Flight 15, even though the demonstration itself remains on SpaceX's published schedule. Now, Flight 14 could prove that Starship can reach orbit, do useful work, and come home. Flight 15 may then have to prove that it can stay in orbit, protect its cryogenic propellant, and wait for a friend to join it. And if that happens, the mission after Flight 14 will be the opening half of the most complex Starship test yet. 2 ships, 1 orbit, and the first real step toward refueling a spacecraft on the scale needed for the Moon and Mars.